Algebra 2, 7, 5, apply properties of logarithms. So we are going to look at the different way that logarithms work today. So we'll start out with the product, quotient, and power properties for logarithms. So here's our product rule. If I have a log, let's say log base b, of two things that are multiplied, say m and n, then I can break this up and say that it's the log base b of m plus the log base b of n. If I have a log, we'll use base b again, of two things that are being multiplied or being divided, because this is quotient, so we'll say m divided by n, then we can break up these logs with subtraction. So log base b m minus log base b of n. So notice when I do this, I'm actually, I have the word log written out twice with the plus sign in between them, or the log sign written out twice. That function's written out twice with the minus sign in between. The last one is if I have the log of something being raised to a power, then I can take that exponent and I can multiply that in front like a coefficient. So n times log base b of m. So we're going to use these properties in many different ways. First, we're going to use these logs. We're just going to play around with those log properties. And so we're going to take, like in part A, log 6, and we're going to figure out how to make that using log base 3 of 12 and log base 3 of 2. So we're going to be using these log properties and just practicing them by working with numbers. So I know that 12 divided by 2 is 6. So I'm going to write that this is log base 3 of 12 divided by 2. And then I'm going to use those properties and say that this is log base 3 of 12 minus log base 3 of 2. So when we have division, we subtract. Remember how logs are related to exponents, and if I had the same base with exponents on the top and bottom, I could subtract those exponents. Well, that's what I'm doing here. I'm subtracting the logs because we know that a log is really just an exponent. So now that I have it written out this way, I'm going to substitute. My log base 3 of 12 is 2.262, and the log base 3 of 2 is 0.631. And then I'm now going to combine them, and that is 1.631. So now on to the second one. I want to take the 24 again. I'm trying to make it out of a 12 and 2. So I'm not using a calculator to evaluate. I'm just using what these two different logs that they're giving me are equal to. So I can say that this is equal to log base 3 of 12 times 2. So log base 3 of 12 plus log base 3 of 2. You know what? I did not write down 2. I wrote down a 12 times 12. So now we fix that. And now we'll substitute log base 3 of 12 is 2.262 plus 0.631. So now we're adding them instead of subtracting, and we have 2.893. The last one, we have log base 3 of 32. So let's see, 12 times 3 is 36, so we're not going to get it that way. But I do know that 2 raised to the 5th power is 32. So log base 3 of 2 raised to the 5th power. So now remember, anytime I have an exponent, I can multiply that in the front. A lot of times I draw that arrow to help students remember as a coefficient. So 5 times log base 3 of 2, which is 5 times 0.631, which is 3.155. So this is one way we can use those properties. Another problem type will be when we say to expand. So expand means we're going to use those properties. We're going to write this as a sum and difference of logs until I cannot use any more of those properties. So we're trying to really break this down. So because I have division, my first step would be to take and break this up into 2 logs of things being subtracted. And this is just base 10, so I didn't write down a base, so I don't have to write down a base. But remember, when it just says the word log, it means base 10. Now, it's really tempting to pull this 2 to the outside, but what I notice is that the x is being squared, not the 3. So before I could make that 2 a coefficient, I would need to break these apart with addition. Because if I'm multiplying two things, then I break them apart with addition. And now that square will be able to go in front. Same thing on this one. It's 5 times y cubed. And remember, if I have a minus sign out here, I would need to have brackets, log 5 plus log y cubed. So make sure you have those brackets because this minus sign is going to have to go to both parts of it. It's going to have to go to all of this log. Then I would pull my exponents in front. So log 3 plus 2 log x minus, and then in brackets right now, we have log 5 plus 3 log y. We are showing an awful lot of work on this, probably way more than what you need to. But remember, when we do notes, we're always trying to add in like all those extra steps. Like I didn't distribute, I could have just written minus in front of them both right away. But we're really trying to show how we got something so you could look back at it later on and figure it out. So now I'm going to distribute my minus sign. So minus log 5 minus 3 log y. So one thing I tell students to always watch out for is because of the way those minus signs distribute, anytime you are trying to look at a log and work the other way around and condense, we call it. So condense is when we take this big string of logs with plus and minus signs, we put them all back together with a single log. Is anything that has a minus sign is really going to belong in your denominator. And from the way we worked out this problem, we can really clearly see that. So next, we're going to look at just a quick multiple choice, what's equivalent. So let's go ahead and simplify this one, and then hopefully it'll be one of our answers. These are all logs of different numbers, natural logs of different numbers with no coefficient or anything, so we should just be able to simplify. So this is really, we're condensing now. Condenses when you put it back together as one log. So there's a plus sign between the 8 and the 5. Oh, and this 2 is going to have to be an exponent. So I'm going to have to write 8 times, and the 5 is being squared, and it's minus log of 10, so that one's going to go in my denominator. So I did that pretty fast. So let's look at that in stages. This would be natural log 8 plus natural log of 5 squared. And then we would take these two, because there's a plus sign, and we'd multiply them. So natural log of 8 times 5 squared. And then because I'm subtracting the log of 10, 10 is going to go in the denominator. So when I'm breaking them apart, I write the log multiple times. When I'm condensing them, I just write it once. So now I'm going to simplify that 8 times 5 squared over 10. 5 squared is 25. And 8 quarters, or 8 times 25, would be 200. 200 divided by 10 is 20. So our answer would be D, natural log of 20. So we had to condense a log. Our last formula that we need today is a change of base formula. So if A, B, C are positive, B can't be 1, C can't be 1, then if we have log base C of A, that's going to equal log base B of A over log base B of C. So I really feel like this is one of those formulas where I've kind of got to break it down and tell you what in the world is going on. So this B is going to be a new base. And then you can see that the A went in the numerator, the C went into the denominator. So that's kind of where everything went. So what we're doing is we're really looking at changing to a new base. Typically, we change to base 10 or base E because we can do those on a calculator. Because then we can use a calculator. So this is a way. So if I have like log base 2 of 3, and I can't figure that out without by hand, right? 2 to no power is ever going to equal 3. We know it's going to be a decimal. Then I could say, well, I want to use base 10. And then I could make it log 3. Remember, base 10, we don't have to write the base, divided by log 2. So that's our change of base formula. So now we're going to practice using that. Log base 6 of 24. So we want to evaluate it using common logs and natural logarithms. So common log is just the word log, like this with no base because it's understood it is base 10. This is the one that's on our calculator. Natural log, remember we write it as ln, and that's base e. So this is going to be log of the big number, and by big number I mean the one that's written, so it's larger. So log 24 divided by log 6. Or we could write natural log of 24 over natural log of 6. And the cool thing about math is we know these should all be equal, and when you use a calculator and you do log 24 divided by log 6, be really careful if your calculator, if you put parentheses around the 24, it might start you with one parenthesis, you'll have to close it before you divide by that log, so be careful about how you plug it in your calculator. But for both of them, you should get 1.77. So I would really encourage you to try that with both of those fractions. Make sure you can get that to work. This is the end of our 7-5 notes.